Hi, my name is Chengxi, 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson, we have these two examples. First example, integral 0 to pi x dx, integral 0 to x cosine x plus y dy. And for our second example, we have double integration x squared plus y squared is bigger or equal to 0 and smaller or equal to 4. Y over x dx dy. So over here we have these two examples, right? So let's start off. For our first example, at first glance, you may think that you can integrate with respect to x already. Well, how you cannot, because that for this part at the y over here, you have parts that contains x that you will need to integrate later. Like the boundary, it goes from 0 to x, and the cosine, there's a x. So what we'll have here is, so apparently for this part we can already integrate for the cosine part. It's just that you have to add the x. While the dx, I'll put it behind because that you'll also have to integrate that part. And then over here for this part, we can integrate and we'll get the sign. And we'll have the boundaries over here from 0 to x, then we have dx. Now we can substitute the boundaries inside for y. So what we're going to get here is, we are going to separate this into two terms, okay? So, first term will be, so if you substitute the x inside, it's going to be x sine 2x dx. While on the other hand, if you substitute 0 inside, whereas you're going to minus because from the boundaries, substitute 0 inside and you get x sine x dx. Now what can we do over here? So for this part we can use the integral by parts. Well, for this part, before you do the integral by parts, these two parts need to be equal, for we are going to put this inside, which are going to end up with a half in the front, and then x d sine 2x. And here you're going to minus. So the sign over here, when you put it inside, it will become a negative cosine, right? So here we have cosine 2x with a negative in front. While for this part, you'll also get the negative in front, so it becomes a positive instead. And here we have 0 to pi x d cosine x. Okay? Alright, now we can move on to our next part, which we will use the integral by parts for both of these, whereas you're going to end up with negative half integral from 0 to pi. So over here, integral by parts, x cosine 2x from 0 to pi, and then after that minus, whereas you have the negative in front, so it becomes positive, and you're going to get half integral 0 to pi. So the cosine over here, cosine 2. So over here we have cosine 2x dx as you put this inside. Well, for this part, similarly for this, you're going to get x cosine x 0 to pi. And then after that, over here for this part, you're going to add, well, actually over here is minus because of the integral by parts. Minus integral from 0 to pi cosine x dx. Now that you have gotten this part, what you can do is you will substitute this to be inside, and when you substitute pi to be inside, you have cosine 2 pi, which is going to end up with a 1. Then when you substitute this inside, you're going to get negative 1 over 2 pi. But over here, when you substitute 0 inside this, you're also going to get 1. But when you substitute the 0 inside, the x is going to be 0. And since it's not indeterminable form and all, you can put it in and you will get a 0, so you can ignore it. Then for this part, you can straight up just integrate it. Whereas over here will be 1 over 4 instead, because that for this part, the dx over here, you need d2x to make it the cosine x, something like cosine x dx, like that. So you're going to get cosine integral will become sine again. So sine 2x 0 to pi. Then here you're going to plus. So when you substitute the 0 inside, you get a 0, right? But when you substitute the pi inside, okay, so here you're going to have pi, but what is cosine pi? Cosine pi is negative 1. So here you're going to minus pi. Well, for this, you're going to end up with minus sine x from 0 to pi. So you can now combine these two, right? So negative 3 over 2 pi. And then this pi, if you substitute pi inside, you'll get sine 2 pi, which is 0. And when you substitute 0 inside sine 2, 0 is still sine 0, which will end up with a 0. Well, for this part, sine pi is 0, sine 0 is 0. So in the end, you can ignore all of them, and this is what we get at last. Okay, alright, so for our first example, what we mainly did was just to integrate. Then after that, we use integral by parts for 2 terms, then integrate again. So just take a quick look before I move on to the next question. Okay, so I'm going to erase this and now moving on to our second question. Over here we have x squared plus y squared is bigger or equal to 0 and smaller or equal to 4 y over x dx dy. So in case you haven't realized already, this is basically a circle. Well, what is 4? Well, 4 is 2 squares, so if you have to draw the area bounded, you're going to get so here you're going to end up with, so this circle over here was the radius of 2, okay, because 4 is 2 square. So 2, negative 2, negative 2. Okay, so for this part over here, so our area bounded is basically this circle for this part. So over here we can clearly use polar coordinates, whereas we're going to have x equals to r cosine theta, and we'll have y equals to r sine theta, which we're going to end up with. So for this part, you have r sine theta over r cosine theta. are going to have our RD theta. Then what about our boundary? For R, it is clearly over here from 0 to 2, right? Yes. So for our R, we have 0 to 2, while for our theta, it's the whole entire circle, so it's 0 to 2 pi. Well, for this part, the R over here, these two R's will simplify. And you're going to end up with integral 0 to 2 pi tangent theta d theta, because sine over cosine is tangent, and 0 to 2 r. Okay, so for this part over here, well, you can choose to just straight up decide that. So because tangent integration is basically secant square. Okay, so secant square over here. Okay, so for this part, tangent is basically sine over cosine, while over here for this part we have sine theta over cosine theta d theta. Then after that, over here for the r, we're going to have half r square from 0 to 2. So what are we going to have here? So for this part, you're going to have, so first of all, this you have half times 2 square, whereas one of the 2 was the 2's will simplify. While here you're also times one over cosine theta. Well, you can put the sine theta into the d theta, which is going to end up with, so you're going to end up with a cosine theta over here with a negative in front. Well, for this part, you're going to get negative 2. So what is the, so this is basically the same idea as dx over x integration. So what's going to happen here is that, so when you integrate dx over x, you're getting a ln, right? So you're going to get ln cosine theta from 0 to 2 pi. So apparently over here we have negative 2. So ln, we have ln cosine 2 pi, whereas cosine 2 pi is basically 1. So here you have, so when you substitute this pi inside, you get ln 1. And when you minus negative become positive. If over here you have 2 ln, and if you substitute 0 inside, since cosine 0 is also 1, so you're going to get 1 here. Well, you can use 2 ways to get the answer. One, and these two just minus each other out and you get 0. Second, ln 1 is basically 0 itself, so you'll still get 0. It's basically the idea of negative 0 plus 0 minus 0, and you get 0. Okay, so for our first example, what we mainly did was we had this part, then after that we did our integrations and all, and we get the sine 2x, and then we use the integral by parts. Well, for our second example over here, what we mainly used was just, so we put this part in, we integrated, get ln, and then ln 1 is equal to 0, or these two just minus each other out. And 0 is the answer. Well, that would be mainly it for this lesson. Stay tuned for future lessons. Last but not least, thank you for your watching.